Well, yeah, thank you so much for being here, everybody. I'm Ben Noren. I recently defended my PhD in chemical engineering. And together with my advisor, John Oakey, we started Celldrop as a way to translate our biomedical research from the lab to industry. We are Celldrop, and we enable fast permanent tissue regeneration for horses to minimize missed competitions and extend their careers. Now, to begin, I want to give everybody a little bit of background about horses, specifically athletic horses. There's dozens of competitive equestrian events that happen all over the world, and there's over 2.5 million horses that compete in the United States, many of which compete right here in Wyoming. Now, much like human athletes, horse athletes tend to get injured because they work really hard, and over 99% develop an injury at some point in their career. Now, many of these aren't a problem because they heal naturally and quickly, but what is a problem is almost 80% of these injuries are to what's known as the suspensory ligament. This is a ligament that spans the lower part of a horse's leg, and it is the equivalent to an ACL, MCL tear in a human. It's very slow healing. It can take years to recover, and about 20% of horses who sustain this injury never recover and are permanently unable to compete. Now, there's two primary ways that this is treated. One of them is with surgery. This is kind of a last-ditch attempt, and it rarely returns horses to competition. Another popular method is with stem cell therapy. The way that this works is by taking cells that can induce healing and injecting them into that injured ligament. They can theoretically stimulate the cells in that area to regenerate that tissue. Now, what this looks like in horses is a veterinarian goes to stable and they draw bone marrow from the horse. They then take that bone marrow, separate the cells from it, concentrate those cells, and inject it back into the injured ligament. This works great in theory, but research has shown that in practice, these cells survive in this area for less than 24 hours. This doesn't give them a very long window of stimulating this tissue regeneration. And because of this, results are pretty minimal in terms of tissue regeneration. Now, obviously this is a problem because there's only these two solutions and they're both time consuming and marginally effective. Now, since we're a biomedical engineering lab, we saw this as an opportunity to improve on this therapy. And so we wanted to see if we could somehow extend the useful window of these stem cells. We used our patented technology in order to take these stem cells and microencapsulate them in hydrogel droplets. This is basically the equivalent of putting cells in tiny, tiny jello marbles. What these jello marbles do is they create an environment around the cell that mimics where it naturally lives in an organism. This protects it and it keeps it from migrating or basically running away when it's injected into the injury site. The way we do this is we take stem cells from a horse, we then grow them up in a lab and to hundreds of millions of these cells. We then encapsulate them using our patented process. And once we have these cells in the tiny jello marbles, we take them, load them into a syringe, and we can freeze them and ship them on dry ice anywhere in the country. So what this does is it enables us to have faster soft tissue healing to minimize missed competitions and more complete healing to extend equine athlete careers. Now, this was really cool technology, but we wanted to make sure that we had the proper product market fit if we were going to actually implement it in industry. To do this, we participated in the National Science Foundation I-Corps program. This funded us to travel around and interview over 100 potential customers. These people included horse owners, horse trainers, and veterinarians. And through this process, we decided that racing horses should be our initial target. We came to this conclusion because we found that horse owners have a major issue every time a horse misses an event because they can lose hundreds of thousands of dollars. This creates a very large pain point for them, which they then pass on to the veterinarian who's responsible for fixing their horse. These horses these veterinarians don't have a good recourse to this, and they really are looking for solutions. From here, we wanted to look at the market as a whole. So we conducted some market research and found that the total available market of the equine industry in this country is nearly $122 billion. Now, this is a huge market and really surprised us. And of this, about 36.8 billion is just with equine athletics. So it's also a very large area. Doing further research, we determined that our serviceable obtainable market, or the market that we have access to in year one, is approximately $8.5 million. This takes into account the racing horses that we plan to initially target and our channels that we can reach customers in this area. In terms of companies that do a similar therapy, there's three primary ones: Advanced Regenerative Therapy, or ART, VetStem, and ProStride. Of these three, both ART and VetStem offer a product that uses stem cells to heal horses. However, what they lack is a way to preserve and localize these cells. This means that when they inject their product into a horse, it is minimally effective. Our major advantage in this market space is that we can preserve and localize these cells at the injury site, which creates much better tissue regeneration. Now, through our ICOR investigation, we interviewed veterinarians, and we found that veterinarians learn about new products by attending events where they're advertised via the web, but primarily through several main veterinary conferences that happen throughout the country. In terms of where they buy their products, we found that they will buy them at these conferences via the web, but primarily through drug reps. Now, this can be difficult for a new company because many of the veterinarians who buy these through drug reps have established relationships with them, and it can be difficult to persuade them to buy a new product. For this reason, we took an approach of partnering with a company that produces stem cells and has these sales channels established. This company is ART, and we decided to partner with ART for several reasons. First of all, they're geographically close, so that they're located in Fort Collins. For another reason, they are already produce stem cells that we can then encapsulate using our technology and produce a value-added product. And we already have an established relationship with them because one of their co-founders is a longtime collaborator of the Oakey lab. In terms of our timeline, we've currently completed extensive in vitro studies in a model of a suspensory ligament that shows that our encapsulated cells have much better viability over a long term. From here, we need to complete a small animal study that will determine safety. We found that in order to solicit investors to earn more money to conduct a large equine study, we need to have initial data of safety in a small animal study. At the conclusion of the small animal study, we'll launch a full study in horses where we'll look at the actual regenerative capabilities in a suspensory ligament injury. At the conclusion of this, we plan to initiate our partnership with ART, install the necessary equipment in their existing laboratories where they culture cells, and from there, we can begin sales. Now, if we are able to raise the necessary money to conduct our small animal study immediately, we estimate that we can begin these sales approximately August of 2021. For this reason, we're asking the Elbogen competition for $10,000 so that we can immediately conduct this small animal study. We plan to pay for the more expensive equine study using grants and investments. We have applied for and received a phase 0 SBIR and in the process of applying for a phase 1 SBIR grant. And we have several angel investors that once we have the small animal data, we can approach about raising approximately $900,000 to perform our full equine study. Now, in terms of our cash flows for the first 3 years, we project based on our Based on ART's current channels for sales, we can conduct approximately 200 treatments in year one. Because we have these established sales channels, we're able to quickly penetrate the market. And because of this, we have a relatively fast 6-month payback period. Because we plan to pay for our initial studies using grants and investments, it keeps our capital costs relatively low, and we're able to turn a $940,000 profit in year one. Now, if you take a look at our cash flow, we begin to accumulate money, and by year 3, we have approximately $8 million. This may seem like a lot, but to sort of tie everything together, what our ultimate goal for this project is to be able to translate our technology into humans. Because our product has wide range of tissue regenerative ability, we want to enable better treatment of debilitating human diseases such as osteoarthritis. However, this is really expensive. Human trials cost a lot of money, and the regulations that we need to meet require expensive clinical trials that can be anywhere from $10 million to $100 million. For this reason, we plan to quickly begin investing in this research and development so that we can translate our equine product into humans and pay for it using the cash from our equine sales. Thank you so much for your attention, and I'm happy to take any questions.
Ben, thank you, and thanks for jumping in and being the first participant in this kind of odd and challenging format. So round of applause for Ben. That was fantastic. And I'm sure there's lots of horse owners hoping for a speedy execution. And as the human who would like that treatment also, I'll just raise my hand for you guys getting to that avenue. Awesome. So with that, I think we will turn over to judges who have questions. And see, I'm getting back to my view. If you want to stop your screen share, Ben, that will help us to be able to see the judges' faces.
Yeah, you bet.
And with that, we've also opened up the chat window for the whole audience. So those of you who do have a question, send it to the send questions here person in your chat list. And we'll try to carry some through if the judges make it through their line of questions. And we will certainly carry forward all the questions for the finalist teams tomorrow. So with that, does a judge want to raise a hand? Or, okay, Stephen, you can go first, and Shane, we'll have you go second. So Stephen, go ahead, and it looks like you're unmuted. So go ahead with your question.
Hi, Ben. Nice work and good presentation. Thank you very much.
Thanks, Stephen.
I'm not sure I understand the viability of the stem within a hydrogel capsule, but what about the functionality? Do you see what the stem cell does for the rest of the tissue slowed down by encapsulation, or?
It's not, no. So we've done a lot of in vitro studies with this, and because our encapsulation process enables like a macroporous hydrogel, so there's big holes in it, we can have the cells basically able to release the trophic factors or the chemicals that induce the healing, and they're able to have an exchange with the environment that in the organism so that they can have nutrients come in and sustain them. So they have equivalent function in these hydrogel droplets as they would in any other tissue.
Very good. Thank you.
Yeah.
Okay, Shane, go ahead, and then we'll go to Susan next.
Hey, Ben, nice work. Always fun to jump off the ledge first, right?
Yeah, it's great.
I'm definitely no brainiac, so I'm going to ask some layman questions here. As far as your intellectual property status, help me understand a little bit more. I've read it here, but I just want to hear it from you. Where are you at?
Absolutely.
I know that you've done this in vitro studies. Where literally is it for a business person? Where are you at with this? Do you have a copyright, a trademark? What exactly do you have? I don't really understand where you're at with it.
Sure. So we have a patent pending, but I'm actually going to turn this over to my co-founder, John Oakey. He is, in charge of the Oakey lab. So he's going to be able to answer this in the most clear terms.
Yeah, so we've been working on this since I arrived at the University of Wyoming in about 2010. We immediately started filing for patents. First, they were big patents that protected the techniques that we use to make these hydrogel particles and encapsulate cells within them. Just keeping cells alive within these gel drops is a challenge. And we've continued to patent around the edges as we've understood more about encapsulating certain types of cells, encapsulating mesenchymal stem cells in particular. To Stephen's question, there's some interesting things that we can do modulating the material properties of the hydrogel space in order to control the excretome and optimize for the therapeutic potential. We're patenting these things. So we're really becoming more granular now in our IP protection strategy and trying to protect our freedom to operate in this space.
Thank you, John. Shane, does that answer your questions, or do you have any follow-up?
What does the minority equity partner mean? What exactly does that mean? Is there a certain percentage that UW is a equity partner in it?
Do you want to take that, Ben, or should I?
I guess I can take that. Yeah. So there's a small percentage, and the way that it works is that like UW holds the patent, and we license that from them as a company because we are using their I guess their runway to actually have these patents sent it through the legal system, and they pay for it. And I believe, correct me if I'm wrong, John, but I believe we it's 60% that we as inventors get, and then we have full control over use of our patents, so we can license it to whomever we want.
Well, as inventors on the university side, the university returns 60% of all royalties to us, which is an extremely generous arrangement. But as the licensees and the entrepreneurs, the university, we are signing a IP licensing and facilities use agreement with the university, which gives us access to essential equipment in my laboratory as well to continue to do this, this research, which is going to make it much cheaper in the long run. And so the university takes, they have a schedule for minimum royalty payments, and they also take a small equity share in the company, or the foundation does.
Okay, thank you both. Susan, we'll turn it over to you for next question.
Great, thanks, Mandy. Ben and John, great work on the science and on the business plan also. It was very well laid out, with incremental steps and explained well. If we go, well, first thought on the technology, the ACL. I come from a family that's had lots of ACL injuries and used stem cell therapies that did not work, so can appreciate the science piece of it. But if you look to the first phase, the small animal piece of this, and describe what you see as your threats or challenges for that first phase, or for that phase. And then when you go to the large animal, the horse piece, what you see as your main threats, kind of what you're focused on to get you from first to that first phase and through it, and then through the second phase.
Sure. Yeah, absolutely. So the small animal study we need to conduct because it's customary to make sure that any sort of a new treatment like this is not going to be toxic to the animal. And so what that will entail is we're going to put our cells and our droplets, inject them into a rat. We plan to partner with Jared Bushman in the Department of Pharmacy here. And then we're going to perform histology to make sure that we don't find these hydrogel droplets in any organs where they don't belong. We're going to look at the liver, kidneys, those types of filtering organs where these could potentially be, they could end up where we don't want them. The chances of this are practically zero because these hydrogel droplets are huge, much bigger than a small molecule like a drug. And so they're going to be localized in the tissue. I guess they're, thousands to tens of thousands of times bigger than even a large molecule would be. And also, it's a minimal risk because we build these hydrogels out of already FDA-approved material. So they're made out of polyethylene glycol. It's something that is in your the fry oil they use at McDonald's. It prevents it from frothing. So it's something that people already are eating on a daily basis, and it's an FDA-approved material. So we're not worried about the toxicology portion of it. It's something that is necessary in order to prove that our method is safe. And from there, going to the horse study, the biggest risk that we run is we have done extensive in vitro testing in a model, but we've yet to actually determine what the parameters of tissue regeneration will be. Because of the way the science works, the longer that the cell is alive and being stimulated by the chemicals released in this injury to basically tell the cells in that injured tissue to heal themselves, the better healing you're going to have. So even with stem cell therapies now that are only minimally effective, they still have some effect despite the fact that your cells are only there for 24 hours. In our models, we show that building artificial tissues that mimic a suspensory ligament and putting cells in, our cells last a week and are still 95% viable after a week, whereas the unencapsulated cells lose viability immediately and are all dead within 24 to 48 hours. So there's a huge difference in the time that these cells can be localized there and be initiating this healing response. Because of this, we estimate about a 50% faster rate of healing than what's currently possible. And that's how we based our financial calculations on, because it's all about how fast you can get the horse back up and running, right? And so the biggest risk we run is that it could be significantly slower than we calculated, and that will only marginally improve our product over existing products. That being said, in our financial calculations, we account for a large range of efficacy enhancement, and we're able to generate revenue with a really big range. So it's not like we're right on the edge of, if it works a little bit less well than we hope, we suddenly don't have a product.
Okay, Ben, I'm going to jump in. I know Walden has a question as well, and it'll probably be our last question because we're running really tight on time.
Got it.
Cool. Thanks again for the presentation. How long can you store the cells? And then I'll have a follow-up question based on that.
Yeah, indefinitely, almost indefinitely. We can freeze them in the droplets and then we can thaw them out. And so if they're frozen at negative 80 degrees, we can store them for theoretically years.
Gotcha. And then is there a market? I know I grew up on a cattle ranch and we raised horses and stuff too. So I know there's a market for semen, eggs, all that stuff, but is there a market for, let's say you go get a Triple Crown winner's stem cells out of their knee to put in a up and coming horse's knee? Will that help strengthen anything? Is there a market for that industry also?
I mean, it very well could be. So right now in sort of experimental cell world, what they're doing is they're looking for cells that have a specific gene expression that will, for instance, you have a cell that will heal cartilage really well. And they take that cell, they isolate that based on its gene, and then they grow it up. That could definitely be something we do for horses as well.
Gotcha. So there would be potential to look at a higher pedigree horse to if they're 100% healthy, they never had health issues, all these things, being able to market that product, that stem cell at a higher price than just a random horse that's coming out of the pasture, right?
Yeah, totally.
Okay.
That's so fascinating. I want some stem cells to make me taller. So with that, we'll do a round of applause for Ben and John. Thank you all so much. Wonderful presentation. And we will ask you now to leave the meeting, as we'll be moving into a break and then welcoming our next team shortly. So thank you once again and have a great day.
Yeah.